So this video is on Double the Love, the calculator section that we had last weekend, just to make sure, again, we're feeling confident with doing the calculator portion for Monday's test. So they're asking us to compute the degree for each of the following. And so in order to go from radians to degrees or degrees to radians, basically we're going to do the following. We're going to multiply, if I'm going from radians to degree, I'm going to have 180 degrees over pi. And because pi and 180 are the same thing, and what I'm going to have happen is the reason the pi is on the bottom is the pi is going to cancel with the pi. And then I can put this into the calculator. And I'm going to have 3 times 180 divided by 13. And I end up with 41 point, let's say 54 degrees. Okay. On number 2, this is radians. Okay. So, and it's 2 radii around the unit circle. So 2, again, I'm going to times it by pi 180 over pi or pi over 180, but since 2 is in radians, I am going to go 180 degrees over pi. Okay, and then I'm going to put that into my calculator. So 2 times 180 divided by, 180 divided by pi, and I end up getting 114.59 degrees. So 114.59 degrees. So now on the next section, we're going the opposite direction. We're going to be going from degrees to radians. So I am going to be timesing it by, this time, pi over 180 degrees. And so what's going to happen is the degree symbols, the units, are going to cancel out. And I am going to get 5 pi over 180. And if I put 5 over 180 into my calculator as a fraction, you see I get 1 over 36. So this is going to reduce down to pi over 36, and that would be my simplified answer. On B, again, same idea. I am going to multiply by pi over 180 degrees. And again, the degree measure, that's going to cancel out, equals. And so I get negative 201 pi over 180. And let's see. Oops. So 201 over 180. Oops, over 180. Sorry. Over 180 is 67/60. So it actually does reduce down. So this is going to be negative. Let me just scooch this out a little bit. Negative 67 pi over 60. And that would be my radians. Okay, so let's take a look at the next section. So here we want to approximate this. We want to round to the nearest hundredth. Okay. So when we're on this problem here, we're going to, since we don't have cotangent on our calculator, we're going to go type in the reciprocal, which is going to be 1 over the tangent of 5 over 8 pi. Now, I'm going to put this in a fraction form, but if I'm not, you have to be careful. And you would go 1 divided by 10 of 5 divided by parenthesis 8. That's supposed to be an 8. 8 pi in parentheses and then parentheses. The 8 pi has to go together, but I'm going to just do it as a fraction. So I am going to do alpha y equal to my fraction. And I'm going to do 1 over 10 of, oops, I did something. 10 of, and I'm going to do it as a fraction again, 5 over 8 pi. And I want to make sure that my calculator is in the units I'm putting in. This is radians, so I need to change my number to radians. Okay. Now, when I do this, I end up getting 4.96 as my answer. So when I'm doing this cosecant one, it's going to get bigger. So when I'm doing my cosecant one, that's going to be, remember, C doesn't go with C and S doesn't go with S. So the reciprocal of cosecant is sine. So I'm going to go sine of 7, 1 over sine of 7. And that is in radians because they don't have a degree symbol there. So my calculator's in radians. I'm going to type in 1 over, let me just get this is fresh. I'm going to type in 1 over sine of 7. And I end up getting 1.52 as my answer. So you got to pay attention when you enter these, whether they're giving you the angle in degrees of radians, and these two are radians, so I need to make sure my calculator says radians. Now this one here is in degree minutes, seconds. I'll enter this a couple different ways. So the reciprocal of secant is cosecant again, as cosine. So remember, C doesn't go with C and S doesn't go with S. So I'm going to go 1 over cosine of 127 degrees, 21 minutes, 8 seconds. I could also type in, I'll do it in a different color. I could also type in 1 over cosine of 127 plus 21 over 60. So what I'm doing is, this is all in degrees. So I have 127 degrees. I have part of a degree. It's 21 out of 60 because it's 60 minutes in a degree, plus 8 out of 3,600 because there's 60 seconds in a minute, 60 minutes in a degree. So there's 3,600 seconds in a degree. So I can type it in either way. So if, and let me change my calculator to degrees. Okay. If I'm doing it the second way, I need to change it to degrees. If I'm putting it in the first way, I don't need to put it in degrees, but let me just have it in degrees right now. I'm going to go alpha y equal, I'm going to go 1 over, and I'm going to do cosine, and I'm going to do the 127 degrees. And to get to my degrees, I am going to do the alpha button. I'm sorry, not alpha, because I want the blue. I want angle. Blue second and angle for apps. So I'm going to do that. And angle. And here is where my degree and my minutes are. Okay. So there's that. And then I'm going to have 21, and I'm going to do the same thing again. I'm going to do second and apps. And this I'm going to hit my minutes. And then I'm going to put in my 8 seconds. And to get to my seconds is going to be on my plus sign. It is green, so I'm going to do green alpha and then the plus sign, okay, to get my seconds. And I am going to end up getting a negative 1.65 if I'm rounding as my answer. Now I can also put it in the other form, 1 over cosine of 127. And then if I'm going to do it where I don't put in the degree minutes seconds, I got to put a plus. 21 out of 60 plus 8 out of 3,600. And you see I got that same answer, negative 1.65. Now, what I want to show you is if my calculator is in radians, okay? So let me put the mode back in radians. And I'm using the degree symbol or the degree minute seconds. I can actually force my answer even if it's in radians, okay? So I'm going to get this again. And again, my calculator is currently in radians, but when I put my degree minutes seconds in, let's see, it should usually force it. This is not forcing it. This is not forcing it. So make sure you keep it in degrees, okay? Make sure you keep it in degrees. Okay, so you can't force it. In this case, it's not working. Okay. So the next section for this, given the central angle is 110 degrees and your radius is 8, round to the nearest tenth your answers and put the units. Okay, so I'm going to draw a circle. Okay, so let's say I get a circle here. And for that circle, my radius is going to be 8. I'll just draw it. Okay, and so let's say that this is 8. And we want a central angle of 110 degrees. So if I'm drawing that in, let me draw it in a different color. Okay, so if I'm drawing that in, let's say that I'm starting at, let's do it this direction. Let's say I'm starting here. Okay, so this would have been 180 degrees on either side, okay? I have 110 degrees, so it's going to be less than 180. So let's just say something like this, okay? That this is my 110 degrees. And so I am looking at this sector, okay? And I am going to be answering 2 questions. If they had asked me for the arc measure, which they did not, the arc measure of that arc would have been 110 degrees, the same as the central. They're asking me for arc length. And arc length, just to make sure everyone understands, arc length is this length here. It's really the part of the circumference that we have, okay? So that's what I'm going to find. So I am going to find my circumference, which is 2 pi r. And I am going to end up having 16 pi as my circumference. Now, I don't have the entire circumference, okay? I only have this portion. I don't have all of it. And what portion do I have? I have 110 out of 180, I'm sorry, out of 360 of the whole circle times my 16 pi. And then I can put this into my calculator and get my answer. Okay, so let's say I'm just going to enter in like this. I have 110 times 16 pi over 360. And I get, as my answer, 15.36. So I get 15.36 inches. That is my arc length. Then I am going to do the same thing, but this time it's area. And area is equal to So, and let me so area is equal to pi r squared. And so the area of the whole entire circle would be 64 pi. And again, I don't have the whole entire circle. I have a portion of that circle. I have 110 degrees out of 360 times 64 pi. And I'm going to put that into my calculator. So I'm going to come up and steal this and just change this to a 64. And we end up with 61 point, let's say 44. So my answer is going to be 61.44, and this is inches squared. And that's our area. So let's take a look at number 5. On number 5, we have a triangle that has a 90-degree angle. So let me just put a triangle down here. Okay. And a 49-degree angle, which I can actually measure here, but close enough. There. Okay, so I have a right angle. I have a 49-degree angle. Okay, we're calling this one C. They want this one to be B. We'll call this one A. And it says round angles the nearest second and sides the nearest 100th. Note triangle ABC means final missing sides and lengths. Okay. And this side here is a 7. Okay. And so for this one, what we're going to do is we are going to, well, easy to find angle A, honestly, because angle A is going to be basically 180 minus 90 minus 49. And that's going to be 41 degrees. So let me put that in here. That's going to be 41 degrees. And I really could do, since I already have a 90, usually what I do is I go, okay, I've got 90. The rest of the triangle is going to be 90. So 90 minus 49 is 41. That's usually how I honestly think about it. And so now we need to find the other missing sides. So this one is going to be little a because it's across from A, and this one's going to be little c because it's across from C. So in order to find A, I've got B and angle B, and I have angle A. Let's see, I think I am going to use the 41 degrees for this one. Okay, I'll do this in green. Because if I use the 41 degrees, I can do tangent of 41 is equal to opposite over adjacent. And then I can have 7 tan 41 is equal to A. And that's in degrees. So we need to make sure I have my calculator in degrees. Okay, so I'm going to go 7 tan 41. And I'm going to end up with, and they want it to the nearest hundredth, so 6.09. So 6.09, that is going to be A. And I'm going to use trig again to find C. So to find C, I don't like to use the one I just found, because what if I got that wrong? What if I type something in wrong? So I'm going to use the 7. And so I am going to do, let's say I do, I'll just do the 41 again, and I'll do adjacent over hypotenuse. So I will do cosine of 41 degrees equals adjacent, which is 7, over hypotenuse, which is C. So I'm going to get C times cosine of 41 degrees equals 7. So I'm going to get C equals 7 over cosine of 41 degrees. And I'm going to put that into my calculator. So I am going to do 7 over cosine of 41 degrees. And I get 9.28 if I round. Okay, and that is going to be my answer. Okay, so let's take a look at number 6. Okay, so on number 6, we are looking at degree. We're looking at cosine. We're looking at a negative cosine. So if I'm trying to figure out where my cosine is negative, cosine is x, so it's going to be negative in these two quadrants here, in 2 and 3. Okay. And what I'm going to do is I'm actually going to find not the angle that gave me this negative cosine, but the one that gave me the positive. So I know where it is in quadrant 1. That's going to be my reference angle. So I'm going to do cosine inverse of, and again, I'm going to keep it as a positive 2516. And I'm going to put that in my calculator and make sure my calculator is in degrees, which it is. So I'm going to do cosine inverse of 0.2516. And I get 75 point, let's say 43 degrees. So I get 75.43 degrees. Okay, so let's say that that's about up here. So that means I have the same here and here. So to figure out both of those, to figure out this one here, I'll kind of highlight it in pink. I am going to take 180 degrees minus 75.43 to get my pink one. Okay, because I was 75.43 short of 180. So I'm going to take 180 minus, and I'm just going to come steal this answer here. And I get 104.57 degrees. So 104.57 degrees. That's that angle. And I'll do this one down here in orange. Okay. And that time I'm going to do 180 plus 75.43 because I'm 75.43 degrees beyond. I'm just going to come steal this. And I'm going to change this to a plus. And this one ends up being 255.43 degrees. And that's my second angle. Number 7 is going to be similar, but on number 7, what's going to happen is we're going to be looking at this in terms of, actually, in this one, we just want the, quadrant. Okay, we want the quadrant that satisfies both of these. So if I'm looking at my secant, remember secant, the reciprocal of secant is cosine. So I basically want, if I want where my secant is negative, I basically want where my cosine is negative. So I'm going to highlight that in, here, I think I'm just going to, so I'll do this in orange. Okay, so cosine is negative here and here. That's where my cosine is negative. Then I want where my tangent is going to be negative, and my tangent is negative here and here. So I want where I have both colors. And so that is going to mean that my answer is going to be quadrant 2. That's where both of those are true. On number 8, I want the reference angle for this, okay? And so if I was going around this unit circle, and I'm going all the way to here, okay? That would be pi, but I can also think of it as 15 pi 15ths. And then if I'm going the rest of the way, all the way to here, so I went all the way around, that is going to be 30 pi 15ths. And then at the tippy top, that's going to be half of 15 pi 15ths. Well, half of 15 is 7.5. So this would be 7.5 pi 15ths. Down here, I'm also going to be going 7.5 beyond 15. So 7.5 beyond 15 is going to be 22.5 pi 15ths. And what I'm doing is I'm just adding 7.5 on. So what's that tell me? That tells me that this 17 pi 15ths is in quadrant 3. Okay, so I'm somewhere in here. And so what I want to figure out is how far off is 17 pi 15ths from pi, or 15 pi 15ths. So my answer is going to be 2 pi 15ths. That's my reference angle. That's how far below the x-axis I am. That's how far off of pi I am. Okay, on B, 299 degrees. Okay, so this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 70 degrees, and 360 degrees. So I'm here in quadrant 4, okay? So I am at 299 degrees, and again, we want to figure, well, how far off are we to that x-axis? So I'm going to take 360 minus 299 degrees, okay? And that's going to be 61 degrees. And that's going to be my answer. That is my reference angle. Okay, on number 9. Number 9 is like the one I did up here for number 6, but 6 was in degrees. This time I'm going to do the same thing, but I want it in radians, okay? So how do I know in radians? Because of this. And so they're giving me the cotangent, and we need to figure out, well, where's our cotangent? I'm going to be negative. And our cotangent is negative in quadrant 2 and quadrant 4, because this is where my x and my y coordinates are different signs. And so that's where I'm going to be. Now, I cannot put cotangent in my calculator. So I am going to be thinking of instead my reciprocal, which is going to be tan of, well, here, let me do it this way. Let me think about it this way, okay? Let me get that back. Okay. So I really am going to try to figure out, let me say it this way, where it is in quadrant 1 to get a reference angle. So I really want to know, okay, the cotangent of what is equal to a positive 5.4358. I want positive so I can figure out my reference angle. Well, again, I can't put that on. So I'm going to be thinking about, okay, where is the tangent equal to 1 over 5.4358? So that means in my calculator, I'm going to do tan inverse of 1 over 5.4358. And it's going to give me my answer, but I want my answer, remember, in radians. Okay, they want it in radians. So let me put that in my calculator. So I want my calculator in radians, number one. And then I'm going to do tan inverse of 1 over, and again, I'm going to put it into positive 5.4358. And oops, I forgot to put in my decimal. So if I want to insert something, there is on this delete button, the word INS, which means insert. So I go to where I want to insert in front of, and I hit second in this, and then I can just type in without having to retype. Okay, so I get 0.1819. So let me say that I'm at, let me do it in a different color so we can see it. I'll do it in purple. 0.1819 radian. Okay, so what does that mean? Well, that means over here, I'm going to be 0.1819 off of pi. So I'm going to be taking pi minus 0.1819. Okay, so let me put that in my calculator. So I'm going to take pi minus my last answer, and I end up with a 2.96 as that radian. I'm going to do the same thing in the bottom, okay? And again, I'm going to be that much short of 2 pi, so I'm going to go 2 pi minus 2.95, sorry, minus 0.1819. And so if I do that, let's see, and did they say how many degrees? I mean, how many units? No, do not. Okay, so I'm going to do 2 pi minus, and I'm going to come scale this again. And I end up with 6.10. So this is one angle in radians, and this is the other angle in radians. Okay, on number 10. So on 10, we want to find the equation of a line whose angle of inclination with the x-axis is 30 degrees through negative 2, 5. So through negative 2, 1, 2, 3, 4, 5. This is where it is. Okay. And I'm going to be drawing an angle through here, a line through here. And we want it to be 30 degrees. I'm just going to sketch this. Okay. I'm not going to be drawing this accurately. So let's just say that this is 30 degrees right here. I want this to be 30 degrees. Well, if I want that to be 30 degrees with the x-axis, that means that my slope needs to be, which is opposite over adjacent. Okay. Let me just do this in a different color. Okay. Again, I'm just sketching. This would be opposite. This is adjacent. Okay. And so that is tan. So tan of 30 degrees would be my slope. Okay. When we first learned slope, it was called the slope ratio. So how am I going to write my equation? I'm going to do it in this form. Y equal m times x minus h plus k, where h comma k is the point it has to go through, and m is my slope, which is going to be my tangent. So I'm going to get y is equal to tangent of 30 degrees times x since that is a -2, it's now going to become a +2, +5. And tan of 30 degrees, remember tangent of 30 degrees, 30 degrees on my unit circle. Okay, let me just kind of sketch real quick. I mean, we put in our calculator, but tangent of 30 degrees on our unit circle. This one is our long comma short, long comma short. So when I'm doing my 1/2 over √3/2 and I clean that up, that is going to end up being √3/3. If you've done this enough, you understand that. So this is going to be y equal √3/3 times x plus 2 plus 5. You can also put tan of 30 in your calculator and get a decimal equivalent, okay? So just to show you that if I was to put in my calculator the square root of 3/3, and if I put my calculator in degrees, and I did tangent of 30 degrees, you're going to see I'm going to get the same answer, okay, which is that 0.577. But √3/3 would be the exact slope. On number 11, if our sine is a -1/3 and it's in quadrant 4, okay, so let me just draw a triangle in quadrant 4. This is our angle theta. My sine is opposite over hypotenuse, so opposite over hypotenuse, and the negative is never going to go with your hypotenuse. Then I'm going to do Pythagorean. Let's call this one x. So I'm going to do -1 squared plus x squared equals 3 squared. So when I work this out, I'm going to get 9 and a 1. So it's going to be an 8 when I do that math. When I take the square root of 8, I can actually clean that up because it's really a √4 times a √2. And a √4 is just a 2. So this over here is going to be 2 √2, and it's positive because of the direction it's in. So then when I think about cosine, cosine is adjacent over hypotenuse, okay? Adjacent over hypotenuse. And tangent, here I'm going to do tangent in a different color just so we can see it. I'll do it over here. So tangent is going to be from here, opposite over adjacent. So that's going to be a -1 over 2 √2. But we have to rationalize that. So I'm going to multiply the top by √2 and the bottom by √2. And when I do that, I am going to end up getting -√2 over 4. And that's going to be my tangent. On number 12, we're going to find tangent of theta, given that theta lies in quadrant 4. Okay, so we're in quadrant 4. Okay, and our cosecant is -4. Okay, if our cosecant is -4, that means our sine, which is the reciprocal, is a -1/4. So that means I have opposite over hypotenuse. And this is again going to be x. So in this case, I'm going to do x squared plus -1 squared equals 4 squared. So x squared plus 1 equals 16. So x squared equals, well here, x is going to equal the square root of 15. So this x right here, it's in the positive x direction. It's going to be a √15. So I want tangent of that same angle. And tangent of this angle is going to be opposite over hypotenuse. So it's going to be, I'm pointing to the right thing, saying the wrong word. Opposite over adjacent. So -1 over root 15. Again, we rationalize. So I'm going to multiply this by root 15, this by root 15. And I end up getting as my answer a negative root 15 over 15. And that's my tan. So hopefully going over this helps you guys a little bit before our test.